All right, everyone, welcome to chapter 16. This is on scheduling. So not just scheduling of people, but scheduling of use of equipment, scheduling production, scheduling shipping, etc. And also the differences between scheduling products, if that's your business, or if you are a business that focuses on services, what the differences there are. So without further ado, as I was saying, it's the timing of the use of equipment, facilities, and human activities. So actually scheduling people for their shifts is scheduling, the use of equipment, the use of facilities, making sure that you are keeping costs low, productivity, and profits high. There are a number of constraints stopping you from making certain scheduling decisions, your capacity that your system actually has. I'm just going to make all 1,000 of these today. Well, you can only make 100 a day, so that can't happen. That's a constraint. The workers that you have available, the skill sets that they have, that's a constraint on scheduling availability, and so on. Right? You can't just do everything exactly perfect because you have to balance all the resources and availability of everything within your organization. We're going to talk about the flow of things through whether it's a high volume or a low volume system. So a high volume system would be like a assembly line or a production plant. A low volume system would be something like a job shop. Think like you make custom furniture or something like that, right? So in a flow system, so anything dealing with high volumes, you want to have a smooth flow of those goods or customers through the system. As you may see, this is familiar to you from chapter 14. The lean operations was all about the smooth flow of goods or materials through a system, right? So high utilization, and just timeliness of everything going through. Usually, if you are a company that makes a product, you don't just make one product. I mean, there's the continuous flow systems like an oil refinery, but even a factory that makes electronic goods or packages foods will have a number of different products that they produce, and so there's going to be some changing of inputs, changing of materials. The requirements to process it are going to change slightly. You definitely want to avoid excess inventory buildup of products because you've got to recoup those expenses. Storing inventory, we've seen, can cause a lot of excess costs. And if you have a disruption in this kind of system, the outputs can be pretty bad because you're usually making such huge lot sizes that it's going to cost you a lot of money if you have breakdowns. So if you're going to be successful, preventative maintenance, one of the keys here, making sure that you replace belts and do oil changes or whatever else before this thing breaks down. Your product mix actually makes sense if you can standardize some parts within a lot of electronics or something like that, that you're building that into the product design, so that you can use the same raw materials and various things, less things to order, less things that could be delayed in the shipping process. You need to be have very reliable suppliers. Make sure that you get things exactly when you need them, that they can get you exactly what you need when you need them, without problems in the supply chain. Job shops, as I was saying, a little bit different, a lot different. This is when you make to order products. Material requirements are different. The processing time is different. You might expect it to take a lot longer for a custom job than for to produce 1,000 units of whatever it is you produce at your factory, right? A job shop isn't just products either. A job shop could be an auto mechanic, right? You come in there with your vehicle, and you don't know exactly what's going to show up that day. It might be several oil changes. It might be a new brake job, new engine. A lot of different things can go wrong. An emergency room, you might have people in there with broken limbs. You might have people in there with heart attacks. You might have people in there with, animal bites or gunshot wounds. And so it's hard to schedule exactly what you need until the job order is received. So there's a lot of complexity in the scheduling of a job shop or low volume system, like those examples. So often, whenever things come in, it's important to visualize what jobs you have, when they need to be completed, when you can expect them to be finished. The Gantt chart is one type of visualization of scheduling, one of the more popular ones out there. It's often called a waterfall chart because, maybe not so much on this one, but you can see, okay, this one's done, and then that's freed up to do these ones, and that's freed up to do these ones, and it kind of steps down and like the water flowing down from one job to another. It shows any kind of idle times or unavailable times for any jobs to be processed at various work centers. And we'll see this Gantt chart revisited a little bit later in this presentation. Terms you're going to encounter this chapter are going to be infinite loading and finite loading. Infinite loading just means you are assigning, whatever jobs to whatever systems. You don't factor in the capacity, so you just kind of get to it when you get to it. Finite loading is you are factoring in the capacity so that nothing is overloaded. Anything that is, over here, right, this would get moved into 4 to fill this in, and this would get filled into this one. And you schedule them at different times because of the capacity. It just really depends on what exactly your business is as to how you would load them, which is to schedule them, load them into the scheduling visualization. All right, let's say that we have a job and we want to know from this point through the future, how long will it take to complete this job? You're asking that question if you were doing forward scheduling. You're scheduling it here, and it takes however long it takes to get done. Backward scheduling, however, says, when's the latest I can start this job and still get it done on time? So as students, you might have asked yourself that question with maybe a homework deadline or a quiz deadline. When's the latest I could start this and still get it turned in and not be late, right? It's due Sunday at midnight. I better start it by, Sunday at 8 p.m. if it's going to take 4 hours to get done, right? That's the latest you should be able to start that. So forward scheduling, backward scheduling, that's something you're going to encounter. And based on rules you've got established for yourself as far as how you're going to process things to keep things consistent, usually you're going to take one of those two approaches. Again, it's going to depend on the industry. Let's skip that right now and go to Gantt charts. So this is back, like I said, it was on the Gantt chart. This might be several different stages or systems. This example is a landscaping project. So you've got drawings and you expect it to take about a week to get approval, right? So that's the approval process. The progress is here in brackets, or how long it took based on the schedule. It went over schedule just a little bit, it looks like, went outside of those brackets. To prepare the site, you expect it to take just over a week. It took about a week and a half. Ordering your trees, ordering your shrubs. You can place the order at the same time. You expected to get the order in at the start of week 4. You got it a little early. You weren't ready to plant yet because you had other stuff going on. So you expected to start planting, or rather, actually, it looks like you did start planting really. You expected to start planting maybe the second day of that week, and then you started a week early because it came in so early. And now here you are with the shrubs. You expect to receive them. You haven't received them. The actual progress bar is not there. And so, you haven't received them. You hope to have them planted next week and get approval in week 7. But by having this loaded like this, to be able to visualize it, you can tell exactly where you are in the process. Is your project on time? Is it on schedule? Is it on, are the costs still going to be on budget, right? You're able to visualize that at a glance at all stages. So Gantt chart, any kind of scheduling chart like this is very important for project managers. All right, let's say you have a bunch of jobs coming at one time. How do you determine what order you start processing them? So what you'll see in this chapter are what's called priority rules. You have, for consistency's sake, rules in place that you're going to always process in this order of things. And so those priority rules that we're going to cover, I believe there's 6 of them here. First come, first serve, right? Simple one. You show up first, you get served first, right? So, you go to the auto mechanic, you come in first. I want an oil change. Okay, I'll process your oil change. The next person's in line. They want their brakes done. Okay, I'll do the brakes done. The other person just wants their windshield wipers done, which would have taken all of 60 seconds to change them both, if that. But they're third in line, so we're not going to get to them for another hour and a half to change their windshield wipers with this system. So you can see it makes sense because the customer got there first, they're served first, but is there maybe a better way of doing things? And depending on the industry, depending on your customer satisfaction desires, depending on whatever your metrics are, maybe that's not the best thing for that, right? If I can go swap out their windshield wipers real quick, maybe it's better to get that done, get the customer out of there. I don't know, hard to say, right? But let's say you did want to do that, you could do what's called SPT, which is shortest processing time. If you had 5 jobs come in, instead of taking them in the order that they came in, you're going to look at what's the shortest processing time. Basically, getting your customers out of there and the job completed as quickly as possible in a total span of time from now till maybe a few hours from now. How many customers could we get done? So if you do the shortest ones first, you can get more done in a shorter distance of time from now. The same total time isn't going to change, right, to do all the jobs, but maybe maybe it makes sense to load it that way in some circumstances. Now, in a business where the customer is actually coming in, walking in, and you say, okay, oh, they came with the shorter job, I'm going to get them done first. Oh, I know you've been waiting, but there's a shorter, I'm going to get theirs done first. As a customer, I might be upset about that. I'd say, I've been waiting here, I was here first, why am I not being served? So again, it's going to be very dependent on the type of business. If it's something where you have to process a lot of things for various customers to fill orders and the customer is not there in the store to see all that, maybe that makes more sense there. EDD, earliest due date. So you just look at which one's due soonest and start work on that right away. This minimizes job tardiness, but if you have a very long task right up front, can cause problems where more tasks are a little late versus being able to get several of them on time and one of them very late. So balancing required there, decision making required there. Critical ratio has to do with a formula we're not going to cover much. Just maybe visit that in the chapter. We're not going to do any quantitative work over that. So you might get asked a question on a quiz along the lines of which of these would be appropriate for this circumstance. So just make sure you just have that on hand to reference. I don't think there's any critical ratio questions on the quiz, but there might be something vaguely about it. Slack per operation, if you remember the process we did where we found the critical path through the business, through the processes. Slack time, if you recall, is the amount of excess time you have available. So again, we're not going to really focus on that much, just something to be vaguely aware of. And then finally, a rush job. There's an emergency. If you're in an emergency room and you've got several people with maybe broken bones or pain of some kind, and then somebody comes in with a gunshot wound, yeah, they didn't get there. There's several people there first, but if you take care of the people with the minor injuries first, that person with the gunshot wound might die. So rush into the front of the line is the idea there, right? Okay. But it doesn't always have to do something so critical. There could be, maybe you have a VIP and you need to take care of them because it just makes sense to, rush in the front of the line. Or maybe, you have a lot of food orders to fill and somebody left and came back and their food was incorrect or something wrong, or you're at a restaurant and their food's been served to them and there's something wrong with it. You come back to the kitchen and say, I need this, I need a rush order on this because even though a lot of other people are waiting on food, this person has been served their food and there was an error. So you need to get that out quicker to them. So it doesn't have to be something so critical as a gunshot wound to have a rush job as far as priority goes. And this rush emergency is usually in place along with one of these other priority rules. So you've established one of these as your as your MO, and then rush would just be jumping ahead of all that. Some assumptions with this is that basically this is just for, a lot of these rules these have to be the place in order for this rule to have taken place. You've seen this in several other times in the textbook, but like on forecasting and decision analysis. But basically, all the jobs. So you've got 5 jobs and you're arranging them, right? You're assuming you're not going to get new orders that come in the middle of you having already rearranged them. The setup time is not dependent on the processing sequences. So the setup time does not affect the processing sequence in every way. It's deterministic. It's kind of built into it already. That's assumed to be part of the total time to complete the project. And then you assume that there's no interruptions in the processing, machine breakdowns or accidents. Sure. Okay, if you're going to measure performance of processing to make a decision on how, if you're going to choose SPT or EDD or whatever your main sequencing rule is, you could look at a situation as far as which one has the shortest job flow time, meaning on average, from the time a customer comes in to the time that it's complete, or a job is started to the time it's finished. But getting the order in and getting it completely out the door, that's job flow time. So if it's waiting to be processed, that's still part of the flow time. So from right now till the time it's done, average all those out to see which one has the lowest job flow time might be important to you as a business. The other thing that might be important to you as a business is job lateness. So this is all of the late times, the average of all the late times, or the sum of all the late times, which again, if you do things based on which one is due the soonest, you're going to have a lower average late time, but possibly a higher sum of late time. Make span. So this is from the time the very first job starts to the time the very last job finishes. This is the sum of all those. If you lay them all out end to end, what's that total time of processing? And getting the make span down as low as possible might be, I think it would always be the same because of the processing time, wait time, and all that. So, but that is a metric, and if there's any way to lower that based on reducing bottlenecks, you'd want to do that. And then average number of jobs, if you recall from the inventory chapter, I did say the work in process is considered inventory. So if I'm in the middle of doing something, that's considered inventory. I've got, I've got a brake job in the middle of being completed on this car, or the surgery happening right there. If it's a product, that's considered part of inventory. You've got completed inventory, you've got raw materials, and you have work in process inventory. So if you want to reduce the total number of jobs that are happening at the same time, average number of jobs is a metric that matters to you. If you have scheduling difficulties, you want to minimize those, well, set a realistic due date. I'll get this to you Tuesday, I'll get this to you Wednesday, I'll get this to you Thursday, but it's going to take 2 weeks a piece to do all these things. That's not realistic. It puts excess strain on your employees, and you're going to be late for the customer, and your feedback is not going to be great. It might cut down on additional orders from those customers in the future if you're not meeting your promises to them. If there's bottlenecks in your operation, get those taken care of so that you can have more things flow. If all of these things are waiting on processing, I have all these different products, and they're made on all these different, in all these different cellular production assembly lines, but they all have to go to this one place to cure or for testing or whatever it is. Maybe have 2 of those things and not just 1 or 3 or 4 more employees working, or whatever you need to do to focus on areas where if I just had this thing improved, the entire flow of the system would be better. And if you have a large lot, maybe it makes sense for you to do some of it now, some of it next week, or at a different later time, so you can help more customers. Instead of having every single one of these things built before you start taking care of other orders, maybe get a bunch of them now. There's one lot, send it out, get a bunch of other customers taken care of, then do another big order for them. That might make sense as well. Definitely worthy of consideration. Not going to cover this just in the interest of time. And okay, so most of that had to do with products if you're producing something, but with scheduling in the service industry, first problem you have is that you can't store excess inventory to help with customer service issues, or like you could with if it was a product. Oh, you need your brakes replaced. Oh, well, we've got a bunch of brake jobs just lying on the shelf. Here you go, on your way. No, it's a service that has to be performed. Oh, you need to get a cast on your leg. Okay, here's a cast. Thanks for coming in. Right? Doesn't work that way. You can't just have that entire service already stocked up, ready to go. You have to perform it. You have to have people available to do that service. So scheduling is tough, and the nature of service request is fairly random. You don't know when it's coming in and what the job is going to be when it does come in. So that is a problem. That might be because of the customers, it might be because of your workforce, it might be because of equipment. So I'll give you just an example from my time in the poker room. I can't open a poker table up unless I have enough players to play poker. So it doesn't matter that I have 12 tables in the room. If I don't have players there, customers there, then I can't open the table up. I don't know how many customers are going to walk in. I have a general idea based on history of when people have shown up, when I have opened up poker tables in the past. I can print out things and forecast the demand, but it varies heavily. The casino is a place where rain is a good thing because people's outdoor plans get rained out. A lot of crossover between golfers and gamblers. And so if their golf day was rained out, they might go and play poker instead of playing golf that day. I have to schedule so many poker dealers to work, and I might have 5 dealers scheduled and 2 tables running. That's too many poker dealers. I could send some home early. I'm sure they'd love to go home early that day if they need the money. They might want the day off. But if I send home too many people to make it a better rotation of dealers through the tables, and a bunch more customers show up, now I can't open that table. So I've saved money on their hourly cost by sending them home early. I've made them happy, but I'm missing out on probably, no, I don't know, $100 an hour or more, $200 an hour potentially. I mean, depending on the table. Yeah, it could be upwards of $200 an hour I'm missing out on because I don't have that table opened up, and I did that to save $7 in hourly wages. Probably doesn't make sense. So it's tough. Scheduling is tough. Equipment as well. I might have a lot of demand, but I only have so many tables. So I got to decide what type of game. Do I open up a higher stakes game because you want to satisfy those customers, or they'll go play somewhere else, or do you want to open up a lower stakes game so that because there's more people that would play in that, even though the rake is lower. So making decisions on equipment. So there's all 3 of those from my time in the poker room, the kind of decisions a poker manager has to make. A couple ways you can deal with demand. You can have an appointment system, so they call and make an appointment, or make if I'm going to get my oil change and I want to make sure that I'm in and out as quickly as possible, I make an appointment. I show up at the time of the appointment, and then I'm good to go. I'm sure there's going to be walk-ins too, so they're waiting, but if there's an appointment, they're ahead of them. Reservation system, very similar. If you book a hotel, you've reserved a hotel, and it's a pretty accurate estimate because most people will show up. But with hotels, if you booked a hotel, that you pay for it generally when you check in, or even when you check out, you usually have your credit card on file, and it actually paid at checkout. It just depends on the processing, but sometimes they will offer you, maybe a 10% discount or just a flat $10 or $20 discount if you pay for it up front when you make the reservations. That gives you a more accurate estimate. It's worth losing a little bit of money as the hotel to ensure that you're going to get that money, and you don't know refund, so you're pretty much going to show up at that point. But it helps to deal with understanding the demand. And if you have a bunch of reservations for this night because maybe there's a big convention in town, you schedule more employees that day, so it helps with the scheduling all around. All right. So this next section is going to mostly deal with what we're covering on the quantitative video, but unlike most weeks, I'm going to cover it twice just because this isn't really quantitative heavy. It's not math heavy. It's a process and method where you have to follow the steps in a certain way in order to arrive at the solution. And I think seeing it twice, seeing it this way, seeing it again in another video is going to help with that. So I would definitely watch this video still. Don't cut it off and flip over to the quantitative video as soon as you might in previous weeks, because we're going to cover it in a lot of detail as far as doing it by hand, whereas you see the Excel method more in the other video. So assignment model is anytime you have a one-to-one matching need for jobs to workers or jobs on machines or equipment or any kind of, really it can be used for any kind of matching this to that with equal numbers. And so it's a three-step process of assigning it with an occasional fourth step, depending on how the numbers shake out. And so the more you see it, I think the less confusing this becomes. So what it says for step one is subtract the smallest number in each row from every number in the row. Well, that doesn't mean anything because this slide really should show this up front. So this is what we're trying to assign. We've got workers, and we've got workers A, B, C, and D, and we need to assign the worker to a job or vice versa. Assign the job to a worker probably makes more sense. And if we do, these are the costs associated with doing that. So if I assign job one to worker A, it's going to cost me $8. And we'll say that's because of how quickly they get it done. They're really good at doing this. They're not as good at doing this. So the longer it takes them, the more money it's going to cost you, or something to that effect, right? That's the idea. But they also could be aptitude. You might want the person with you might want the highest score too. Then that's different. That'd be more like profits. But assuming these are, we want the lowest number associated with each worker because it's cost related. So that first step said, subtract the smallest number in each row from every number in the row. So do this entire thing and then create a new table with these numbers. So what you do is you have the initial table, and then you're going to draw a new table under that. And it's going to have every row reduced by the smallest number in that row. So on this one, the smallest number in this row is 2 right here. So every one of these numbers is going to be reduced by 2. This will become 6, 4, 0, and 2. And then this row, the lowest number in this row is 6. So I'm going to reduce every number in this row by 6. 6 minus 6 is 0, 1, 5, and 4. The lowest number here is 3, 0, 2, 4, and 3. You're just reducing it by the lowest number. Lowest number here is 5. Minus 5 is 5. Minus 5 is 7. Minus 5 is 4. And then you create an entirely new table with those numbers. So I've reduced everything by 2, 6, 3, and 5. And these are the new numbers down here. I've subtracted the smallest number. So that's step one. It's called the row reduction step. Step two is the column reduction step. I'm actually going to do the exact same thing, except I'm going to reduce all the ones in column A, B, C, and D by the lowest number in those rows instead. So in this one, the lowest number in row A or column A is 0. So with the column reduction step, it will not be uncommon for you to have several of the columns not reduced at all because there's multiple zeros. There's going to be at least one 0 in every row, but anytime they, if they're all 4 in 4 different rows, then you're not going to reduce it at all. If several of the zeros ended up in the same column, then you're going to have to reduce some. So this one, the lowest one is 0, right? So I take 0 away from everything. In this one, the lowest one is 1. So I'm going to take 1 away from everything in this column. 4 minus 1 is 3. 1 minus 1 is 0. 2 minus 1 is 1. 5 minus 1 is 4. So I'm just copying it down into this third table. I started with the original numbers. I reduced them all by the lowest number in each row. Now on this new table, I'm reducing all of those by the lowest number in each column. And I flip to the next one down, okay? So I do that the entire way down. And now here's where it gets a little tricky. And this is going to sound weird, but if you're taking a quiz and you have this kind of question, grab some toothpicks. And this will make sense to you in a second. I mean this literally. Grab some toothpicks because The method now says, and this is the Hungarian method, so blame the Hungarian who invented it. You now want to see how many lines you can draw and cover up every zero. Straight lines, not diagonal. And if that number of lines, the minimum number of lines, is equal to the number of rows or columns, then you're good. Otherwise, you have to do an extra modification. So what I mean by that is this is why I said the toothpicks, arrange the toothpicks to see how many of those it takes you to cover up every zero in your new drawing, if you're doing this by hand. So there's one toothpick, there's another toothpick. Try to cover up as many zeros with one as you can. So I covered up 3 of them there, 2 of them there. And then this last one I can cover up, I'll go this way with it. And you can go either way and it works out to be the same. I could have gone this way instead. It will come out the same. In fact, just to keep it consistent with what's on the next page, I'll go ahead and draw it the same direction. All right, so every zero is covered up. I've covered up all 3 of those ones, all of those. And it took me 3 lines to do that. So I can only stop right now if the minimum number of lines is equal to the number of rows. There's 4 rows, there's 4 columns. So if the minimum number of lines right now was 4, I'd be good. The minimum number of lines is less than 4. So I have to modify this again. What I have to do is I have to modify these 6 uncovered numbers. One more time, because I'm not good enough to make an assignment yet. I need more zeros. So what you do, and this is the only step that is tricky. So since only 3 lines are needed and the table has 4 rows, this is not the optimum solution. The smallest uncovered value is 1. You look at the smallest number that's not covered by lines, and that's 1. 1, 4, 1, 4, 7, 2. The smallest number of those 6 uncovered numbers is 1. So what I'm going to do is I'm going to subtract 1 from each of these numbers. So 1 becomes 0, this becomes 3, this becomes 0, this becomes 3, this becomes 6, this becomes 1, okay? So I've scratched out all of these, and I've modified all of the uncovered ones by the smallest uncovered one, which would probably be okay if that was it, but there's one extra step, which is these intersection points. Anywhere where my lines intersected, I have to add 1 to those numbers. You just do. So the lines intersected here and here. This was a 0, it becomes 1. This was a 6, it becomes 7. Yep. So here's what we're left with. We're left with, and then every other number. So these 6 numbers here that are covered with a single line, and these ones down here, 0, 0, 3, 0, 0, 0, 5, 2, they just copy over to the next one. So this is basically creating a 4th table. And in this 4th table, these ones copy over. The 6 and the 0 become a 7 and a 1. These are all reduced by 1, and you have a final table, okay? And now once we've done that, we can make the assignment. The number of lines to draw, if it still takes 3, if I can still cover with 3 lines, I have to do that again, but it doesn't. It takes me 1, 2, and we'll say 3, 4, right? So it took me 4 lines. I can't do it 3 lines anymore, so I'm good. Anytime it takes me the same number of lines as there are rows, then I'm good. I can stop and make the assignment. And when you're making the assignment, you're matching up. You want to look for the lowest values that you can assign these workers to, which hopefully should be a 0 in every situation. So what I'm going to do is I'm going to look for any rows where I have a single 0. If there's 2 zeros, I've got a decision to make, and either one is a possible optimum solution. But I want to look at any row where I have a single 0 in, because if that's the case, then I'm going to start by assigning that first. And I see a single 0 in this row. So at job 2 to worker B, that's a single 0. And because job 2 is now assigned, I know that I'm not going to need to assign these. And worker B is assigned, so I know I'm not going to need to assign those either. I can just eliminate them from my possibilities because that's assigned now. There's 2 zeros in this row still. There's 2 zeros in this row. So job 4, I see that there's only 1 0 in this row. So I'm going to assign job 4 to worker A. And at this point, I can't assign those because job 4 has been assigned. And I can't assign those because worker A has been assigned. So now I've got job 1 and 3 unassigned. And if I look at this, I see that job 3 has a single 0. Job 1, it's still up in the air. So I'm going to assign job 3 to worker D. Now job 3 is assigned, so that can't be it. Worker D is assigned, so that leaves only job 1 and worker C. So these are my assignments: 1C, 2B, 3D, 4A. And when I do that and I make those assignments, I revert back to the original costs, way back on the original form. That's why you don't want to erase it, you just want to draw under it. And 1C was $2, 3D was $6, 4A was $5, and 2B was $7. I add that up. 2 and 7 is 9, plus 6 is 15, plus 5 is 20. And so that becomes my total cost. And that's it. And we're going to work that again on the problem set video, so it'll make a lot more sense, seeing it step by step all on one Excel sheet, I think. But again, because it is methodology based and not so much, difficult formulas, I want you to have the chance to see that a couple of times, working through it a couple of different ways. So thanks, everyone. I'll see you on the problem set video. And that's all for chapter 16's lecture.